All right, clip number 3 of Chapter 11, Section 1 notes. This part C, I wasn't able to fit into the last clip, so I'm just going to finish this problem out right here. Again, these types of problems, it's really about translating the information given in the diagram to what I need for this formula on arc length. So in this diagram, it's just important to understand what I'm seeing. 15.28 meters is the distance between R and T. So this you should be able to translate as the radius of the circle. And then this 44 meters, and here's where you need to be careful, because in some cases it might tell you in degrees, or in some cases it might give you a unit of distance, and they mean two very different things. So had this been 44 degrees, and obviously it's not degrees, this is an obtuse angle, but had this been in the measurement of degrees, that would be referring to the arc measurement in degrees between those 2 points. The fact that this is in a unit of distance, in meters in this case, this is now the arc length, the actual walking distance between R and S along this curve. Okay, so be careful of that. That will be the giveaway though. If it's in degrees, then it's the numerator here of this part. If it's in a unit of distance like we're seeing right here, then it's this side of the equation, the actual arc length. Okay, but again, let's translate the information that we're given. Again, instead of the letters A, B that we were told in the formula on our notes, it would just input R and S for those letters. Again, there are 3 pieces of information I need, one of which I will not know. Arc length is something I need for this equation. In this case, that is this explicit distance written right here. That would be the 44 meters. That would end up being my left side of the equation when I plug it in. The other piece of information I need is the actual measurement of that arc in degrees. So this would be RS, just to use their letters. And I would want to know either the central angle right here. Notice that that's not given in degrees. Or I would have to be told this arc measurement in degrees on the outside. You'll notice that that's not given either. That is a distance measurement for arc length already. So this is the piece I'm being asked for. And then the other piece I need is either the radius, diameter, or circumference to plug into this piece right here. As this is written, it would be radius, which is what I need here, or what I'm given here in the diagram. They could have also given me like the full diameter of the circle, in which case I would simply divide by 2 to figure out radius, or I could just do pi times diameter there. Or like in that last example, instead they were asking for the entire circumference. They might give me the entire distance around the circle, in which case that's just all of what 2 pi r is. So I could replace that with circumference. So in either case, no matter which way it's given, it's just going to be one of those elements, either radius, diameter, or circumference. In this case, it is radius, and based on the diagram, it's 15.28 meters. So as I plug stuff in and solve for the pieces I need, arc length here would be 44 meters. So left-hand side would be 44. This is my unknown. The piece I'm solving for is the measurement of that arc. And then radius is 15.28. So when I multiply this together, it'd be 15.28 times 2, which comes out to 30.56 times pi. If you're rounding the answer, I could use 3.14. If they want exact solution, I keep pi there. I would divide by this answer over to 44, and then I would multiply by 360 to solve for that arc. You can see that worked out in the solution sheet on Google Classroom. Essentially, when you're asking for an arc measurement like this is right here, it's basically asking you for what portion of the pizza is this slice based on these dimensions. Okay. Anyway, that concludes our examples on arc length. You can see particularly B and C worked out in our solution sheet on Google Classroom. But now I want to talk about our last topic of Section 1 notes, and it involves a concept called Radian Measure. And it may seem a little dense, particularly here at the top. You see that same arc length formula, and there's a description. This right here is basically just telling you what radian measure comes from, and that's the formalized definition. Okay, I can let you explore that. But essentially, this is just going to be, this topic right here is going to be about something called conversion. conversion. This is the same kind of concept that's done when I convert between inches and feet, like we did in that previous example. Okay, if I had 1,200 inches and I wanted to figure out how much that was in feet, I would simply divide by 12, and I'd find out that that's 100 feet. Okay, they're both the same distance, it's just different units. What we're going to find here with this concept is it's the same thing. In one case, I have degrees, the thing that we're probably more familiar with. But another unit of measurement for that kind of object is something called radian. Okay, so what is radian measure? Formally at the top there, a radian is the constant of proportionality between an arc length and that arc's central angle. Basically, it's this. And we kind of saw it here in this formula, right? This is the same arc length formula from before. It's not like anything different. But there is a proportionality. There is a proportionality between basically the length in like an actual distance, length of a crust of a pizza, and the angle measurement that makes that slice. The bigger the angle, the longer that crust, in proportion to the size of the whole crust, right? And what you can find is that there is a constant rate of proportionality, a constant of proportionality, more specifically. And so that constant is what we describe as a unit of measure that we call radian. And that's just kind of where it comes from. But let me get to this point right here, because this is really just going to be the punchline. This right here is going to be our conversion between radians. Radians are going to use the pi measurement, right? So every time you see something measured in radians, it's going to involve pi, whether it's left in this term of pi or it's using a decimal 3.14. Whereas degrees will obviously have that little degree symbol right there, that little circle up there. Again, this will be the one that we're more familiar with. We're just introducing this new measure of measurement called radian. And for those that are doing math in your head, you may be confused right now. You're like, wait, 2 times pi. If I were to actually do that in a calculator, 2 times 3.14 is nowhere close to 360. But here's where it's important to understand this. Write it off to the side in your margin, wherever you need to. This right here, this comparison, this equality, is the equivalent of me saying 12 inches equals 1 foot. It's a unit conversion, right? It's the same distance, but it's using 2 different units. It's like converting between pounds and kilograms, like converting between meters and feet, converting between miles and kilometers, okay? There is an equivalent rate between the two. And so 360 degrees, degrees being a unit of measurement, which 360 degrees is a full circle, is the equivalent in radians to the number 2 pi. So another thing to be aware of here, a half circle, which would be 180 degrees familiarly, would be a single pi. Okay? So this is simply a conversion. I'm not saying that this number here, what would happen here on the left, equals this number on the right, because just like I wouldn't say 12 equals 1 for 12 inches in a foot versus 1 foot in a foot, right? They're 2 different numbers, but it represents the same measurement. This is a conversion between those 2 units. So how do I apply that? You're going to get a couple of problems where you're going to be asked to convert between 2 units of measurement, these units being degrees and radians. So how do I convert between the 2? Well, if these 2 are equivalent, much like 12 inches is equal to 1 foot, if I am converting between one unit to the other, I'm multiplying by a fraction of that conversion. So the fact that these 2 equal each other in unit conversion, 2 pi and 360, 2 pi over 360 is just 1. Because in a fraction form, anything over itself, even if it's different units, 5,280 feet versus 1 mile, if I'm comparing the 2, in a fraction form, it just reduces to 1. So when I multiply it by something, I'm not actually changing any value. I'm simply converting between units. So 2 pi over 360 or 360 over 2 pi, It's 1. It's just converting between different units. So how do I know which fraction to multiply by? If I'm given something in degrees, I want those degrees units to cancel out with degrees in the denominator. Meaning if I'm converting from degrees to radians, I need 360 degrees in the denominator to cancel out with the degrees of whatever object I'm multiplying by. If I'm in radians, which will involve pi, I want to cancel out that pi in the denominator. And so I'd want 2 pi in the denominator in that case, which just forces 360 up top. So let me do 2 quick applications of this, 2 quick examples. This is representative of what you will see in your test what you will see in your final hint. You'll get a problem or two where you're converting. But let's see what that would do. Okay, let me jump to the whiteboard. Part A. You are asked to convert 45 degrees into its equivalent measurement in radians. It's like I gave you some length in inches, and I'm asking you to convert it into feet. I'm going to multiply by the conversion ratio. So in this case, I'm going to multiply 45 degrees times some fraction. And that fraction is going to be either 2 pi over 360 or 360 over 2 pi. It depends on what I'm converting to. Because I'm converting to radians, I want to get rid of the degrees symbol. So how do I know which one goes where? If I want to cancel out degrees, I need this denominator to be in degrees. So this denominator here will be 360 degrees, which forces the other guy, 2 pi, to be in the numerator. This technically is over 1, for the record. So when I multiply this, I'm just multiplying straight across. 45 times 2 pi gives me 90 pi. 1 times 360 gives me 360. The degrees will end up canceling. But now I would do, this is technically now in radians, but now what I'm going to do is I'm going to reduce the fraction. 90 and 360 reduce. It might take you a couple tries if you're not familiar with it, but 90 goes into both top and bottom. 90 goes into 90 once. 90 goes into 360 4 times. This reduces to 1 pi over 4. There is my fully reduced radian form. Important to understand here, 45 degrees and pi over 4, exact same measurement. Exact same measurement. If you were to draw an angle of 45 degrees, pi over 4 radians would be the exact same angle. It's just different units. And if I were to convert this radians back to degrees, I should get back to 45. Okay, let's move on. Part B. Now you're going to be given radians and converting to degrees. Surprise, surprise. In this case, you're told, all right, now you have 3 pi over 2 radians. You need to convert that to degrees. Again, if I'm converting, I'm doing this multiplication problem, so I take that object that I'm converting, in this case, 3 pi over 2. I'm going to multiply it by, again, a fraction. This fraction is going to reduce down to 1, so I'm not changing any value. But I want to cancel out the radian part, which is going to be this pi, and I want degrees to be left over. So if I want to cancel out pi, I need the pi element to be down here in the denominator, which is 2 pi. That forces the 360 degrees up top. Again, just like before, multiply numerator to numerator, denominator to denominator. 3 pi times 360, or just 3 times 360, is 1080. You can trust a calculator there. There is a pi there attached, so just travel along with it. Denominator, 2 times 2 pi is 4 pi. Again, the whole reason why pi is in the denominator, notice what happens here with the pi's. They cancel. And I'm left with 1080 over 4. If I were to do that in a calculator, 1080 over 4 comes out to 270. 270 what? Degrees. Again, understanding that 3 pi over 2 in radians and 270 degrees, if I were to draw that angle, exact same measurement. It's simply converting between the two units. But that concludes our section 1 notes on circumference and arc length. And I'll go ahead and stop the clip right there.